Okay, problem number 2 is asking us, according to the function g double prime of x, which x coordinates are inflection points for g of x? So we're actually given g double prime, all right, the second derivative, and what we have to do is find the inflection points for g of x. So some key annotations here are, first of all, inflection points, specifically how they relate to our double prime value. We know that that's where it changes concavity. So an inflection point will have two things in common. The g double prime will be equal to 0. All right, and the other thing we know is that g double prime will change from positive to negative or negative to positive. So we actually have to know, okay, is it changing concavity, concave up to concave down, vice versa, and will it have a double prime value of 0? So the first thing I would do is actually make this the case first. So let's actually set this equal to 0. And let's solve this really quickly to see what values would give us a 0. Well, since it's factored and these things are multiplying, we can set each one of these equal to 0. And either way, we would get x equals 0 or x equals -2. Now, in a perfect world, this would be enough to tell us that these are inflection points, but we just don't know if it's changing concavity here. We just know that the second derivative is 0, but we also have to see if it's changing from positive to negative, negative to positive. So the best way to do this is to set up your number line. I'll put -2 to the left because it's smaller, and then 0. And just like these problems often call for, we have to plug in numbers and actually test them in our second derivative right here to see if things are positive or negative. So some numbers actually would plug into this interval would be like -3. Anything to the left of -2. Anything in between -2 and 0 would work, so I'll choose -1. That's really nice. And anything to the right of 1 would work, like 1. So for this, I'm actually going to plug these in and see what I get. So let's actually find the f double prime value of -3. So let's just plug in a -3 into the second derivative here. We square it, and then we add 2 to it, and then we multiply those two. So that's going to give us a +9 times a -1. That gives me a -9, which really I just need to know that that's negative. That on that interval, this thing is concave down. It's not decreasing, it's concave down, because remember that the second derivative tells us concavity. All right, now we have to check in between -2 and 0 what's happening. So we're going to try -1. And we're going to do the same process where we plug it in. And that gives me a +1 times +1, which is just going to give me 1, which is a positive number. So that tells me that in this interval from -2 to 0, we're concave up. And then lastly, we're going to plug in f double prime of 1. We're going to get 1 squared and then 1 plus 2. And I'm going to skip some work here. I just know that this is going to be a positive answer. It doesn't matter what the number is, because that tells me that this entire interval is concave up. So why did we need to know that? We needed to know that because not only did g double prime need to be 0 to be in an inflection point, right, -2 or 0 were our possible answers, we also needed g double prime to change from positive to negative or negative to positive to change concavity. So it went from concave down to concave up right here, but then it stayed concave up. So there's only one value where it is an inflection point because it meets both of the criteria. So notice the annotations. Notice what I needed and what I needed to look for first. Notice my second derivative test off to the side and how I actually found that inflection point.